In this video, we're going to learn how to solve quadratic equations by completing to square. Now let's look at this example. Here I have x squared minus 6x plus 4 equals 0, and I'm going to use the method of completing to square to solve this. Now first of all, I have to complete this expression to square, so I start with minus 6 divided by 2. So it's minus 3. So I should focus on x minus 3 squared, which basically is x minus 3 times x minus 3. So this will give me x times x being x squared, x times minus 3 will give me minus 3x, minus 3 times x will give me minus 3x again, and then I will have, last but not latest, minus 3 times minus 3 plus 9. So if I simplify this, I'm going to end up with x squared minus 6x plus 9. Now, instead of 9, I have a 4 here. So it should be that, I start with x squared minus 6x plus 9. So to get 4, I have to take away 5, right? So basically, this is x squared minus 6x plus 4 written in this form. And then, this bit, x squared minus 6x plus 9, I can write this as a perfect square. So it's going to be x minus 3 squared minus 5 equals 0. Now, this is the equation with the perfect square. So I wrote it by completing the square. Now I'm going to solve this. So let me just clear this up for more space. Right. Now I'm going to go on solving this. Now that this is a perfect square expression, if I add 5 to both sides, leaving the perfect square expression alone, like x minus 3 squared equals 5, because these are crossed out, I can now take the square root of both sides. Right? If I do so, I'm going to get rid of that square. So I'm going to end up with x minus 3 here. And here, just because I'm taking the square root of 5, at the moment, I don't know if it is a plus or minus value, so I have to write them both, right? So it's going to be plus or minus square root of 5. And then, if I add 3 to both sides to leave x alone, so basically I'm now solving a linear equation, right? I will cross these out. I will have, let me write here, x equals, now that I add 3, I can go like 3 plus or minus square root of 5. Now this means I have two solutions, like x equals 3 minus root 5 and x equals 3 plus root 5. So there are two answers as expected to my, quadratic equation. Right. Another example. Right. Now this one has x squared plus 10x minus 1 equals 0. We start with dividing 10 by 2, so it's going to be 5. And I will, of course, consider x plus 5 squared. This will be x squared plus 10x plus 25. And you can see that I go like x squared plus 10x plus 25, and here the first two terms are the same. I have to make this 25 minus 1, so I have to take away 26. Right, and this bit I can rewrite it as x plus 5 squared minus 26. So I'm going to take 26 to the other side by adding 26 to both sides. So I will have x plus 5 squared equals 26, and then I can take the square root of both sides, and then I'll have, let me write here, x plus 5 equals plus minus root 26. Now I have to take away 5 from both sides. At this point you can start writing the two solutions. You can say x, if you want x1, yeah, equals minus 5. Generally we write the integer to the front, minus root 26, and then x2 being minus 5 plus root 26. So that's totally okay if you just write these down. Now keep in mind, in these examples we didn't have that. Keep in mind that this square root expression, this third, must be in its simplest form. Here root 26 is root 26. You cannot simplify further. But if we were to end up with square root of 32, then instead of writing it, we should be including 4 root 2 instead. So you can use a calculator to simplify thirds. Now there are cases that you can use completing to square, however, you may not find a solution. So let me give you an example like that. So you do completing to square, you try to solve the equation, but because of the square root thing, you won't be able to solve the question. So suppose that we have plus 28 here. Right, again, the same things, so it's 10 divided by 2, it's going to be 5, so it's going to be x plus 5 squared is x squared plus 10x plus 25, and x squared plus 10x plus 25 plus 3, this gives me 28, right? And this bit I can write as x plus 5 squared, so I will have plus 3 remaining here. And now, if I apply the same method, taking away 3 from both sides to leave the perfect square alone, I will have x plus 5 squared equal to negative 3. Again, I'm going on with the method, so I take the square root of both sides. Here is the problem. The square root of a negative number does not exist. So at this point, either I'm going to stop and double check all the work that I did, if there's a mistake or not, or after that, if I'm sure that there's no mistake in my work and I end up with this, then I'm going to say no solution. Why? Because I cannot take the square root of a negative number. This is not a real number. So I cannot go on with my solution. I cannot say x plus 5 equals square root of negative 3, and it's going to be a plus minus. So it's not going to be like x equals minus 5 plus square root of negative 3. You can write these down, but it has no meaning, as square root of minus 3 is not a real number. And it will be A levels when you learn that this actually is a number, but it is not real, it is complex. Right? So the chances are, if you end up with such a situation, it's going to be a no solution thing, because we don't have a real solution. Right, so please solve these equations by completing to square and submit your answers online. Thank you.